due to common challenges faced by humanity such as climate change, environmental pollution, and oil shortages. New energy vehicles have become a key to addressing these challenges and solving problems. With the rapid breakthroughs and developments in various technologies of new energy vehicles, they have become popular options for customers to purchase. Yet the diverse range of new energy vehicles can be overwhelming. So, how are new energy vehicles classified? What are the criteria? Let's learn about the classification of new energy today. According to the promotion of new energy vehicles in China, we can roughly divide new energy vehicles into electric vehicles and new fuel cell vehicles. Due to various technical reasons, new fuel cells have not yet been fully popularized in our lives. So today, I will mainly introduce common electric vehicles. Electric vehicles can be classified into three types: pure electric vehicles, plug-in hybrid electric vehicles, and extended-range electric vehicles. According to different charging methods, you may wonder which one of these three has the most advantages. Different charging methods have their own advantages and disadvantages in terms of convenience and economy. Pure electric vehicles can only be charged by an external power source, and the motor provides power for the vehicle. Pure electric vehicles refer to vehicles powered by onboard power sources, driven by electric motors to travel on roads and comply with various requirements of road traffic safety regulations. Pure electric vehicles are entirely driven by rechargeable batteries, and their basic structure is not complex. The motor and onboard battery are key components, with the battery being the most critical, with the challenge lying in energy storage technology. Pure electric vehicles have various advantages, such as strong power, fast acceleration, simple structure, and lower operating costs compared to traditional vehicles. The electricity consumption per 100 kilometers is 13 to 18 kilowatt-hours, with electricity costs around 0.65 yuan per kilowatt-hour. The cost per kilometer is only 8 cents to 12 cents. In terms of maintenance, pure electric vehicles do not have the periodic maintenance requirements of fuel vehicles, resulting in lower maintenance costs. However, there are also disadvantages, including range anxiety, inconvenient energy supplementation, unsuitability for long-distance travel, and low resale value. Of course, with the improvement of more and more charging facilities now, the demand for pure electric vehicles is increasing. According to GBT 19596-2017 terminology for electric vehicles, an extended-range electric vehicle is a type of electric vehicle that can achieve all its power performance in pure electric mode. When the onboard rechargeable energy storage system cannot meet the range requirements, the onboard auxiliary power supply device is activated to provide energy to the electric system, extending the vehicle's range. The onboard auxiliary power supply device is not mechanically connected to the drive system. In other words, extended-range electric vehicles have an onboard gasoline engine that provides energy to the battery without directly powering the vehicle. Extended-range electric vehicles are only driven by the motor, with the engine not involved in propulsion but solely responsible for charging the battery, making them more suitable for long-distance driving, because it can provide power to the electric motor through the engine, ensuring a longer range. Its advantages include long range, refueling capability, convenient energy supplementation, and eligibility for green license plates. Disadvantages include high fuel consumption at high speeds, rapid battery drain, and reduced power. It is suitable for individuals who want to buy new energy vehicles, but have inconvenient charging facilities and long-distance travel needs. Plug-in hybrid electric vehicles are much more complex than extended-range electric vehicles, as they add an electric drive system on top of the fuel system. Both the fuel engine and the motor drive the vehicle, enabling it to operate in pure fuel mode or hybrid mode. Hence, plug-in hybrid electric vehicles have two sets of power engines. Power output can be achieved through two methods: charging by the fuel engine, and external power source for both the gasoline engine and the electric motor. Its most prominent advantage is fuel economy. which can save 30% to 50% more fuel compared to conventional gasoline vehicles, significantly reducing emissions. It can be charged and refueled, eliminating range anxiety, suitable for both short and long distances, eligible for green license plates. However, it also suffers from issues such as complex mechanical structure, high maintenance and repair costs, relatively high failure rates, high prices, and inefficiency over long distances. Therefore, it is more suitable for short-distance travel. In short-distance electric mode, achieving zero fuel consumption or high-intensity use, with diverse and complex usage scenarios. Fuel cell electric vehicles. Fuel cell electric vehicles utilize fuel cells to directly convert the chemical energy in fuel into electrical energy for power drive, representing a new type of vehicle. Compared to pure electric vehicles, the primary power source of fuel cell electric vehicles is fuel cells rather than batteries. The fuels used in fuel cell vehicles include hydrogen, methanol, etc. Globally, high-energy density liquid hydrogen is commonly used. The energy conversion efficiency of fuel cells is 2 to 3 times higher than that of internal combustion engines. And they do not produce harmful emissions with low noise. From the perspective of energy utilization and environmental protection, fuel cell vehicles are ideal vehicles, representing the future direction of clean vehicle development. However, there are still technical challenges in the development of fuel cell vehicles. Other new energy vehicles. Apart from electric vehicles, there are also vehicles powered by other energy sources such as hydrogen engine vehicles and natural gas vehicles. For example, hydrogen engine vehicles not only have the advantages of pollution-free and low emissions but also have high combustion performance and mature internal combustion engine technology. However, the difficulty lies in hydrogen production and the storage of liquid hydrogen. Whether these two major problems can be solved determines the development prospects of hydrogen engine vehicles. Natural gas vehicles have low pollution, low cost, high safety performance, but poor power, are not easily portable, and planning costs for refueling stations are high. Ethanol vehicle technology is relatively mature, with traditional internal combustion engines needing minor modifications. But China is still in the initial stage. Now, do you have a further understanding of new energy vehicles? Mastering the definition of new energy vehicles and being able to describe their classification can lay a solid foundation for future in-depth research and learning. The essence behind the emergence of new energy vehicles is actually the improvement of people's awareness of energy conservation and environmental protection. Faced with a series of problems such as glacier melting and climate change caused by greenhouse gas emissions, new energy vehicles can be regarded as an effective remedy. However, from the introduction of this lesson, we can also find that while there have been some technological breakthroughs in new energy vehicles, there is still a long way to go. As frontline engineers in the future development of new energy technologies, we should always maintain an innovative spirit, study hard, and contribute to the development of science and technology in our country.